Hey everyone. Today we're going to talk about a new OKE feature which allows you to automatically replace the boot volumes for your OKE worker nodes. In my example, I have a node pool here called pool 1. This is a node pool consisting of two worker nodes. These worker nodes are currently running version 1.31 of Kubernetes, and they are both in a ready and active state. So if you've used OKE before, you'll know that we have a feature called node cycling. Node cycling, which is found in the top left of this page, allows you to replace your worker nodes in cases where you need to update the worker nodes. So you need to update the Kubernetes version, or you need to update other attributes of those nodes, such as the image, operating system image you are using. Now, when you are replacing these nodes, you have the option of determining the maximum surge, or in other words, the number of additional nodes that should be added for the cycle, and the maximum unavailable, which is the maximum number of unavailable nodes during the cycle. You mess around with these settings in order to find the right balance for your application's availability. So, for instance, in my case, I have two nodes here. Let's say I want to add one additional node for the cycle and make it so at max, only one of my nodes can be unavailable at a time. So if I go ahead and cycle the nodes here, you'll see that it will go into an updating state. And in just a few moments, we will see that the nodes will actually start spinning down and new nodes will start spinning up in their place. This feature is wonderful if you're trying to achieve high availability within your cluster, as you can determine the number of available and unavailable nodes during the cycling process. So in a few minutes, we will see that a new set of nodes will be here and the old set will be replaced. Okay, now you can see that we have two new nodes and they are both in ready and active conditions. So this feature has been in OK for quite some time. So what is new here? So what we saw here was us replacing the nodes entirely. That includes the compute and the boot volume. However, not all scenarios do we need to actually replace the compute itself. In many cases, we just need to replace the boot volumes, such as in cases where we are updating Kubernetes or using a new image, or just modifying the size of the boot volume itself. In that case, we can take advantage of the new feature, which is replacing the boot volume. And replacing the boot volume is very similar to replacing the node, but instead of replacing both the boot volume and the compute itself, we are just replacing the boot volume. So the logic is very similar. Here, when replacing the boot volume, we just specify the maximum available that we can have at a given time. So if I want only one node to be unavailable in my node pool at a time, I would specify one. If I wanted two, I'd specify two, and so on. Here, what happens is rather than the node terminating, the node is shut off, the boot volume is detached, and a new boot volume is attached to that node, and the node is restarted. So we can see here, the node is going into an updating state, and in some time, we will see that these nodes will have new boot volumes attached to them. Okay, so now we can see the nodes are ready and in an active state, and the boot volumes have been replaced on them, but the nodes themselves have stayed the same, as you can see here. Now, there's one other feature I'd like to show before I go into the terminal, which is the ability to reboot nodes. So if you click on the arrow on the side here, you'll see we have actions here. If you click on actions, you'll see that we have this button cycle node, and in the cycling options, we see we have an additional option, which is reboot node. So rebooting nodes is useful in cases where you don't want to replace the node or the boot volume itself. Maybe you suspect there's some sort of hardware issue, or something along those lines, and just a reboot will solve the issue. So one thing that's unique here is in the past, if you wanted to restart a node, you would have to do that from the instance service or the compute service. However, in that case, pod disruption budgets were not respected, and pods would be forcefully evicted without any sort of eviction grace period in those cases. However, with reboot nodes, we can set it such that it must respect the eviction grace period, and nodes or pods are not forcefully evicted unless you explicitly tell it so. For instance, here I can set the coordinate drain. Let's just set it to something really low, say 1 minute, and then we can tell it to force action after grace period. What this will do is the node will wait 1 minute for all of the pods on the node to be evicted and scheduled elsewhere. And if that 1 minute passes and not all of the pods have been evicted, we will force the shutdown in that case. So let's go ahead and try this. So we can see that the node is in a state rebooting, and shortly we'll see that the node will have been rebooted. All right, now we can see that our node has been rebooted. So those are the new features. However, there is an additional way for you to actually accomplish this. So what I showed you was replacing the boot volumes and rebooting the nodes from the console. However, you can do this from both the console as well as the CLI. And something new that has been added is the ability to replace the boot volumes and reboot the nodes from the Kubernetes API. So with this new feature, we have released a new custom resource called the NodeOperationRule. NodeOperationRule is installed by default for enhanced clusters, and there's no additional setup necessary to use this feature. So a NodeOperationRule is essentially a rule for you to tell the Kubernetes control plane that when nodes fit this particular condition, in this case, if they match a trigger label, then you should perform a certain operation on this node. So going from the top, we have the node operation rule. We have the name of the rule. In this case, I'm calling it replace boot volume. The action that this rule should execute. In this case, I'm telling it to replace the boot volume. Then I have a node selector in which I'm using this particular label, the node operation label, with the key value replace my boot volume to tell the control plane when I have a node that has this label, execute this node operation rule upon that node. Optionally, we can match custom labels to these nodes as well. Um, Here we have the parallelism. This is telling us in parallel how many nodes should this node operation rule affect at once. So for instance, if I had a node pool or a set of two nodes that I was restarting and I set the max parallelism to 2, then both of those nodes would be affected by this action at the same time. Similar to the console, you can set the eviction grace period. In this case, I'm setting it to 1. The unit is in minutes. And the is force action after grace duration to true or false. This is saying after the eviction grace period has expired, should we force the action or should the operation fail? In order to actually tell the control plane which nodes this action should be enacted upon, you have to label those nodes. So for this example, I'm going to go ahead and replace this node right here. So in this case, I'm setting the key to node operation and the value to replace my boot volume. And I'm going to go ahead and do the same thing to this node right here. So I'll go ahead and copy and paste that. Okay, now that I have those nodes labeled, all I have to do is create this node operation rule. So I'll go ahead and apply this manifest. Right? So I created the node operation rule. Now I'm going to go ahead and search for these using kubectl get nor. And I can see the name of the node operation rule and the node selector. Now let's go ahead and describe this. And we can see it described right here. We can also query the events as well to see when this node operation rule takes effect. Right? I went back and described the node operation rule, and we can see in the events here, 5 seconds ago, started node operation on node with work request ID. And it'll give us the OCI work request for this particular operation. So if I go ahead and run kubectl get nodes, we can see the status of the node as it is being shut down and the boot volume uh, detached and reattached with a new one. So in this case, this particular node, which is indicated here in the event, 10.0.10.6.1, has been cordoned and is being drained. And once that happens, uh, it will be it will be shut down. While we are waiting on this, I will go ahead and share another action that you can do with the node operation rule, which is reboot. So I showed that in the console earlier. However, you can also run that reboot operation on nodes using the Kubernetes API using the reboot action. So the principle is the exact same. You specify the action, you specify the trigger label, in this case, the node operation, and any node with this key or with this label will be affected by this node operation rule. Here we can see that the node is coming up after being restarted and is now ready. Once that node is up and running, we can see that the next node is now being cordoned and drained. Once it is completed, you can go ahead and query the node operation rule to check its status. If we look at this, we can see the succeeded nodes, so the name of the node affected, the success timestamp, and also the events. So when it started the node operation alongside its work request ID, telling you when it completed operation on each node and when it completes. All right, I hope you all enjoyed that. This is a wonderful new addition to the OKE ecosystem, which gives you even more ways to improve the manageability and maintenance of your worker nodes.